Hello, welcome to my recorded classes. This recorded video, we are discussing the topic from Module 1, 1.1 section, Propositional Logic. This is a topic from the course Discrete Structure, Math 2200, Discrete Structure. So, let's start the content here. So, Module 1, Logic and Proofs. So, first you can see some applications of the applications that involve the topic in this module. Actually, logic, propositional logic, where we are using mainly, we can mention some of the applications here, just here. Propositional logic, we are using in artificial intelligence, as you know. Also, in the gates, okay, different gates, we are using the logic ideas, and also design of computer circuits, construction of computer programs, and other application, verification of the correctness of program. A lot of applications are there. Also, one live application you can see here in from information and communication technology by using the logic, especially strategic focus on automated driving. Okay, you can see this example here, automated driving. There also we are using this logic ideas. Okay, so what are the topics in this module? You can see first section 1.1 propositional logic, and the second one we are studying predicates and quantifiers, 1.3 rules of inference, and 1.4 proof methods, especially direct method, by contradiction, and by cases like. Okay, so this video we are concentrating in the first section 1.1 propositional logic. Okay, so let's start the first topic 1.1. So first I will tell you what are the ideas we are discussing here in this section. After that we will do the questions one by one. Okay, so ideas briefly I will tell one by one. Propositional logic first. Okay, proposition. What is the meaning of proposition? A proposition is a declarative sentence. Okay, that means it is either true or false, but not both. Okay, so proposition means it is a declarative sentence. That sentence should be either true. True means we are representing capital T, or it should be false. Okay, but not both. Okay, if it is not a proposition, we are calling it is a non-proposition or not a proposition. For example, you can see some example here. Muscat is the capital of Oman. Muscat is the capital of Oman. It is a true statement, correct? So we can write the value is true, correct? The sentence is true. So what about this statement? We can say this is a proposition, correct? We can say it is a proposition because the declarative sentence either true or false. Here we are getting true option, so it is a proposition. Now the second one you can see 1 plus 2 equal to 10. 1 plus 2 equal to 10. Actually it is a false statement because 1 plus 2 means 3. 3 never equal to 10, correct? So it is a false statement. False statement also we are calling it as proposition, correct? Either true or false. Now the third one, this sentence is false. This sentence is false. We don't have correct information to say true or false like that, correct? It is just a paradox. So we cannot say anything about that once. We can say it is a non-proposition, correct? It is a non-proposition. Okay, now the fourth example. What a beautiful bird, correct? It is just an exclamation. We cannot say detail. We don't know the details. What a beautiful bird, correct? So we can say this is a non-proposition, correct? This is a non-proposition. Now the fifth example. What is your name? What is your name? It is just a question, correct? We cannot say like a true or false like that. So this is also we can say it is non-proposition. We can say this is non-proposition. So I hope you understood what is the meaning of proposition. So proposition means it is just a declarative sentence, either true or false. Now we will go to the propositional variable. What is the meaning of propositional variable? So proposition now we are representing by using some variables. Okay, that is we are calling propositional variable. Especially we are using P, small letter P, Q, R, S, like this English letters. Okay, for example, today is holiday. Sorry, today is Friday. Today is Friday. For example, this is a proposition. Today is Friday. I am representing that by using a propositional variable that is calling P. Okay, I am using the variable P here, small letter P here. You can put a semicolon after that. Okay, for just for understanding, P means today is Friday. Today is Friday, that declarative sentence, just using a propositional variable. Using P we are representing that one. So I hope you understood what is the meaning of propositional variables. Okay, so we can use P, Q, R, S like letters, any letters we can use. Now what is the meaning truth table? Okay, now just before we discuss it, truth value of a proposition is true if it is a true proposition, correct, and it is denoted by capital T, while it is false if it is a false proposition, and it is denoted by capital F. So as I told you, true proposition we are representing by using capital T, and false proposition we are representing by capital letter F. Now for example here, now truth table, you can see truth table means we are writing the truth value using a table. Okay, we are writing propositional variables and truth value by using a table. That is what we are calling the truth table. For example, first column we are written the proposition. P is the first proposition, then Q is the second proposition. What is the P proposition? The sun rises in the east. Correct? We know sun rises in the east. It is a correct statement. So what is the true value of that one? Truth value of that one? It is true statement. Correct? Now Q, for example, the statement Q, the sun rises in the west. It is a wrong statement. So it is false. We can write the false truth value in the second column. So truth table means proposition corresponding truth value we are writing like a table. That table we are calling as truth table. Okay, so that is the simple idea. Okay, now let's go to the next idea. What we are discussing, logical operations. So this section, okay, what are the logical operations we are using? For example, mainly we are studying this section, negation operation first. Okay, we are studying first negation operation. Negation, you can use this symbol or this symbol. Okay, both are I am using here in this topic. Conjunction, conjunction means this symbol we are using. Disjunction, this is the symbol. Exclusive or we are calling XOR operation. Exclusive or operation, otherwise XOR operation, we can use this symbol. And conditional statement we are using one-sided arrow. Biconditional statement we are using double-sided arrow. So these are the logical operation we are discussing this section. So negation, this operation. Conjunction, conjunction means the symbol we are calling AND symbol. Disjunction means we are using the OR symbol like union and intersection, or and. And XOR operation we are using this symbol. And conditional, one-sided arrow, biconditional, double-sided arrow. So we will discuss one by one what are the truth values of these operations, logical operations. Okay, so first we are going to do negation. Negation of P. We have a statement P. What is the meaning of negation of P? So negation of P we are representing either like this, or we are using this symbol. Two symbols we can use. One of the symbol negation P or negation P. So this symbol we can use, or we can use this symbol. Correct? So what is the meaning negation actually? Not, that is the meaning negation. Not P. Okay, negation P means not P. So for example, with the truth value, we can see the truth value of the negation statement. So for example, the proposition, see the truth table I have drawn here. In the first column I write the proposition, and second one, what is the negation value, negation of that proposition. For example, proposition truth value true. First one true, proposition is true. Second one is false. So true statement negation means false. Just opposite to that one, not true. Not true. Not true means false. Same like false statement negation means true. Not false means it is true. So negation means just opposite that, true become false. False negation means true. For example, here you can see one English sentence example also. P, the sun rises in the west. The sun rises in the west. What is the truth value of that one? It is false because sun rises in the east, correct? So truth value is false. Now how we are writing negation of that statement, opposite of that statement? It is not the case. We need to use this word not. That is the meaning negation. So negation of the P means the first English sentence opposite. This, it is not the case that the sun rises in the west. Okay, that means sun not rises in the west. That is the simple meaning. So it is not the case. That is commonly we are using for writing the negated statement. It is not the case that the sun rises in the west. The sun rises in the west means P. So it is not the case, that means negation, not, especially not. So this is the meaning negation of a sentence, negation of a proposition. Okay, now we will go to the second operation. That is we are calling conjunction operation, correct? Conjunction operator. So conjunction operation, let me discuss. P and Q are the two proposition. Okay, conjunction operation means P and Q are two proposition. The conjunction of P and Q denoted by like this, P and Q. This symbol we are using, P and Q. It is the proposition P and Q, reading like this, P and Q. That means this symbol, conjunction symbol, this symbol we are reading it as and symbol. It is like intersection and. Okay, so we can see this one. Okay, the truth table. What is the truth table related to the conjunction operation? Now before coming to the truth table, how many propositional variables are here? P is there and Q is there, correct? We have two propositional variables. Okay, P is the first variable, Q is the second variable. So when we are getting two propositional variables, how many columns, or sorry, how many rows will be there in the truth table? See here, first row, second row, third row, fourth row. How many rows will be there in the truth table? So for that, we have, for example, two variable. If we have two variable, one variable is P and second variable is Q, correct? So if we have two variable, 2 power number of variables, that is the rule, that many rows should be there in the truth table. So what we can write that one here? How many variables we have? We have two variables. Okay, we have two variables here. So how many rows? Number of rows, I can write here, number of rows in the truth table. Number of rows in the truth table equals 2 power number of variables. Okay, 2 power number of variables. That means 2 power, what is, how many number of variables are here? 2 variable. So 2 power 2 means 4 rows will be there in the truth table. So how we are discussing that 4 rows, how we are writing that one? The first proposition, either it will be true or it will be false, correct? First proposition either true or false. Now followed by second proposition. Second proposition means first proposition true, for example. Second, either it will be true or it will be false, correct? Same way, if first proposition is false, second proposition either it will be true or it become false, correct? So these are the idea. So how many truth values for P and Q we can create? P and Q. How many truth values we can create for P and Q? For example, the first one. First P is true, second also true. So we can write true and true, correct? Now how to write the second one? For example, first proposition is true, second one is false. So we can write true, false. Same way, first one false, second one true. So we can write false and true. Now same way, false and false. So we can write F and F. So how many rows are there? We are writing, this is first row, second row, third row and fourth row, correct? This is first, second, third and four row will be there in the truth table. So how we are discussing that one? Number of rows in the truth table means 2 power number of variables. One more example I can show to you. For example, I have 3 variables in the truth table. For example, P, Q, R, correct? So how many rows should be there in the truth table? So we can write number of rows, correct? number of rows equal to 2 power, how many variables are here? 1, 2, 3 variables, correct? We have 3 variables. So we can write 2 power 3. That means it should have 8 rows there. 8 rows. So how we are writing these 8 rows? You can see the first proposition, either it will be true or it will be false. Correct? Now the followed by second proposition. For example, first proposition true, second one either true or false. Same way, first one false, second one is either true or false. Same way the third one. Okay, first one true, second one true, third one either true or false. We can do the branching like this one, correct? True, false, and here also true, false, and here also true, false. We have one tree diagram for that one. It is easy to write the true and false that rows by using tree diagram. Okay, I hope you understood. So what are the P, Q, R rows here? First true, true and true, correct? So we can write T, T and T. Second one true, true and false. So T, T and F. Now third one true, false, true, correct? So true, false and true. Now the fourth one T, F and F. Now after that we will go to here false, true, true, correct? So F, T and T. Then we go again F, T and F. We will continue up to the end. F, F and T and F, F and F. So you can see how many rows are there in the truth table. 1, 2, 3, 4, 5, 6, 7, 8 rows, correct? So how we are deciding how many rows will be there in truth table related to this rule? We can use 2 power number of rows, number of variables, 2 power number of variables. That means 2 power 3 here. So it is equal to 8 we are getting. So we will come back to the conjunction operation now. Conjunction, what is the operation? Conjunction means, so I am created one truth table here. So here only 2 variables here. So 2 power 2, that is 4 rows should be there in the truth table. So you can see what are the 4 rows. As I told you just before, what are the 4 rows? This like this: true, 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 false, false, true, and false, false. Correct? So I am written here true, 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 false, false, true, and false, false. Now what are the truth value? P and Q. Correct? Conjunction operation. P and Q. What is the truth value? So true and true. You can see the table. Yeah, first one true, second one true. So true and true means what is the value? True, correct? Both are true means the statement will be true. Now true and false, what is the answer? False. Now false and true, what is the answer? False. False and false, what is the value? False. So and operation only getting true value if both are true. Correct? If both are true, answer will be true. Otherwise, all the case answer will be false. So true and true only true. All other cases answer will be false. That is the truth table related to the conjunction operation. Example, for example here. Now how we are writing this and operation in English? You can see here. It is rainy today. P means it is rainy today. And Q means today is a holiday. Now what is P and Q? That is the question. What is P and Q? How can we write in English? So what we do, first write P statement. It is rainy today. Okay. Then and means this operation. Today is a holiday. That is Q. Okay. So just write logically. Okay. It is rainy today and today is holiday. Correct. So that is the conjunction of these two statements, P and Q. Hope you understood how we are writing conjunction. What is the truth table? How we are writing in English. Okay, now let me go to the third operation here. That is disjunction operation. Third one is disjunction operation. Now what is the meaning disjunction operation? Let P and Q are two proposition. The disjunction of P and Q denoted by like this. P or Q. Okay, P or Q. And it is the proposition we are reading like this, P or Q. So or symbol we are using this symbol, we can call it as or symbol, P or Q, P or Q. Now so you can see what are the truth table. So here also we have two variables P and Q. So how many rows should be there in the truth table? 2 power 2, 2 power number of variable, that means 2 power 2 means 4 rows should be there. You can see this is the first one, second one, third one and fourth one. So proposition P and Q truth values, true true, true false, false true and false false, as I discussed before. Now what is the truth value of disjunction operation or operation? For example, true or true. What is the answer? It should be true. True or true. So is true. Now true or false. True or false means it is true. And false or true means also true. False or false means the truth value is false. This is the or operation we are defining. So here you can see here what happened here, both are false means answer will be false. All other case it is true. Okay, both are false means false. That means one of the statement is true means answer will be true. One of the statement true means answer will be true. Both are false means answer will be false. So that is the disjunction operation or operation. Now let me see one English example here. P, he is walking. Q, he is talking. So how to write P or Q? P or Q. So how to write? First we write P statement. That means he is walking, or okay, instead of this symbol we are using or, then we are writing Q, he is talking. So that two statement using disjunction operation, how to write in one, he is walking or he is talking, like that. Okay, hope you understood the meaning of disjunction operation. Okay, now let me go to the next one, exclusive or XOR operation. Okay, exclusive or operation, you can see exclusive or operation, otherwise we are calling XOR operation. Okay, we are using this symbol for that one, exclusive or XOR operation. Now how we are reading that one? P XOR Q means it is a proposition P or Q but not both. P or Q but not both. Okay, P otherwise Q, or symbol, you know, or symbol, correct? P or Q but should not be both. So this is small difference compared to or operation. Okay, that means just before we discussed the disjunction operation, this table. So you can see what is the, where is the difference coming in XOR operation. So here you can see P and Q, 2 power 2 variables only, so it should have 4 rows. So you can see what are the 4 rows. First, true XOR operation, true. Okay, true, first one P is true. Okay, XOR operation true. Both are true means answer will be false. That is the statement here I mentioned, not both. But not both. Not both should not be true. Both true means answer will be false. One of them true means answer will be true. For example, you can see the second one, true or false. True XOR false means true, because one true here. False XOR operation true, because one true here means answer will be true. Both are false means answer will be false. Okay, F. So when it will false will come, either both F should be false, both true also false. So this table, and just before we discussed disjunction operation where it is difference, both false means XOR also it will be false, but both true means XOR operation it is false, but in OR operation it is true. Okay, there is no other difference. So keep in your mind that idea, both true false, both false also false, other case it is true. Now we have one example here. For example, P, A greater than B, that is the P statement, A greater than B. Q statement means B greater than A. Now if you are using P XOR Q means what we are doing, A greater than B, that is the P statement, or okay, or B greater than A, that is the Q statement, but not both. This is important, that is important in XOR statement, but not both. So it should have this or, but not both. These two statement will be there, either or statement. Only or means it is disjunction operation that we are studied just before. Or and but not both means it is or operation. Okay, hope you understood. Okay, now we will come to the next idea, conditional operation. Conditional operation or implication. We are telling implication, implies. See one side arrow like this. Okay, so conditional operation or implication. Let P and Q are two operations, two propositions. The conditional operation P and Q is denoted by, we are using this symbol P arrow, one sided arrow Q, or P implies Q, is a proposition. How we are reading that one? If P then Q, that is the meaning of P one sided arrow Q, or P implies Q. P implies Q means we are calling it as P implies Q. What is the meaning? If P then Q, that means if P is true then Q also true, like that. Okay, if P then Q, that is, so if coming means it is one sided operation, if and then. So these 2 points keep in your mind, if and then. Okay, if it is coming, it is a conditional operation or implication. You can see the truth table of this one, how we are creating the truth table. For example, true implies true, correct. True implies true means it is correct, true, because truth will be implies truth. So true implies true, that is true statement. Now true implies false, that is a false statement. True cannot be false, correct. So true implies false means false statement. Now false implies true, false sometimes true, correct. So it is true. False implies true means true, and false implies false means that also true, correct. So this case, implication case or conditional statement, okay, true implies false except all it is true, correct. True cannot be false, that case is false, all other case it is getting true value. So keep in your mind this idea. Now in this conditional statement, one important point you need to note that the proposition P is called hypothesis, that means the first column. This is, we are calling this statement, we are calling hypothesis. Okay, hypothesis. And Q we are calling the conclusion, Q statement, this one. Okay, this is, we are calling the conclusion. That means what you need to be careful when we are writing one arrow mark here, whatever statement here we are calling the hypothesis, and here whatever it is calling the conclusion. So P is hypothesis and Q is the conclusion in the before table. So this is the truth table for conditional operation. Now for example, P, you learn discrete mathematics, that is the meaning of P. Q means you will find a good job, that is the Q statement. So P implies Q. How we are writing P implies Q statement? So as I told you, if you put so the arrow mark, one sided arrow mark, if and then, this is the idea. So if, now write the P statement. You learn discrete mathematics. P means you learn discrete mathematics, comma, then you write what is the Q statement. Okay, Q statement you can write after that. What is the Q statement? You will find a good job. So if, then P statement, comma, then you can write a Q statement. That is the conditional statement or conditional operation or implication. Hope you understood. So how we are writing? If, okay, then you write P statement, whatever it is, comma, then you can write the Q statement. So this is what when we are writing in English, the conditional operation or implication. Okay, now let me go to the some important remark. You can see the following propositions are logically same. We can interchange with one another. So some logically same statement you can see, P implies Q, correct. That means normally we are using like this one, if P then Q, correct. If P then Q. Now we can use like this also, Q, comma, when P or Q, whenever P. This also we can use for the implication statement. Or you can see Q is necessary for P. Q statement is necessary. This word necessary. Necessary means the one-sided statement, conditional statement or implication or arrow, one-side arrow. Q is necessary for P. and P is sufficient. See Q here, see you can see Q and P. Q is necessary for P. That means this one Q is necessary for P. Now P is sufficient for Q. Okay, P is sufficient for Q. This sentence also we can use for that one, that arrow. So when you are saying English words, you can careful like this. Q necessary for P means that also P implies Q. P sufficient for Q also P implies Q here. Okay, now let me go to the some other point also before coming to the next operation. Converse, inverse and contrapositive. This is very important idea. What is the meaning of converse? What is the meaning of inverse? What is the meaning of contrapositive? Okay, for example, statement. First I am writing a statement, then I am writing what is the converse of that statement. After that I am writing what is the inverse of that statement, then contrapositive. For example, statement. Okay, statement is P gives Q. That means if P then Q, if P then Q. Okay, so you can write here the connective, logical connectiveness, connectives also I am used there. P implies Q. That means if P then Q. Now what is the converse of that statement? That is first we are discussing. What is the converse of that statement? Converse means just write in reverse. P implies Q. Just write Q first, put arrow P. This is what calling converse of that statement. Converse of the first statement. So how to read that one? If Q then P. Correct? Because we are using reverse order. That's why if Q then P. Hope you understood that one. How we are writing the converse of a statement. Just a reverse order. Okay. If Q then P. Now we will go inverse. Inverse means if not P then not Q. That means just negation of the statement. Negation of the statement. That means this P gives Q. Just to take the negation. Negation of P gives negation of Q. This is what we are calling converse statement. Okay. So how to write that one? P negation means not P. Correct? If not P then not Q. That is the meaning inverse of the statement, original statement. Now we are going to do what is the meaning contrapositive. Contrapositive. Contrapositive means this converse statement negation. Converse statement negation. How to write that one? Negation of Q implies negation of P. That is the meaning contrapositive. So what is the meaning? If not Q then not P. If not Q then not P. That is negation of Q implies negation of P. So this is the three term, converse, inverse and contrapositive. So statement, how we are finding converse of the statement, inverse of the statement and contrapositive. Now here one example is there. Statement, if two angles are congruent then they have same measure. So two angles are congruent. This is calling P. They have the same measure. This is calling Q. Okay. As I told you, if and then. If comma then coming means implication. Correct? One conditional. So P implies Q. That means P implies Q, where P means two angles are congruent. Q means they have the same measure. Hope you understood. Now how to write the converse of this one? Converse means what we need to write? We need to write Q implies P like this. Correct? That means first if, okay, comma then should be there. Then after if what you are writing? Q statement we are writing. This is Q. That means two angles have same measure. Then you write P. They are congruent. Then they are congruent. Or we can write if two angles have same measure, then that two angles are congruent. That is the meaning Q implies P. Just reverse the order. P, Q write first, then P write like. Now inverse of that statement. What is inverse? Actually I told negation of P implies negation of Q. Correct? Negation of P. That means P statement add note. Q statement also add note. Note statement. Okay, implication. So how to write? First if, because arrow mark is there, if and then should be there. Then negation of P. How to write negation of P? P statement opposite. Two angles are not congruent. See, you can see that not statement. That is important, not, correct? That is the meaning negation of P. Then they do not have, not, do not, negation Q, correct? They do not have the same measure, that is the Q statement. So negation of P implies negation of Q. So just write that sentence using not, okay, if and then because of the arrow mark. Now contrapositive, contrapositive means what I told, contrapositive, negation of Q gives negation of P, correct? Q statement not and P statement not. If and then common because arrow mark. So start with the if and then after that we are writing negation of the Q statement, correct? Negation of to Q means they have the same measure, that is the meaning Q. So two angles do not have the same measure, then they are not congruent. Using the not symbol we are using not congruent. So that is the contrapositive of that statement. Hope you understood these three from a statement, how to find the converse of the statement, inverse of a statement and contrapositive of statement. Okay, now let me go to the last operation, that is the sixth operation, biconditional operation or by implication. Biconditional operation or by implication. So you can see biconditional, biconditional means double arrow, double sided arrow, that is the biconditional operation. Now what is the meaning? We can discuss. P and Q are two operation. Biconditional operation of P and Q denoted by using this symbol double arrow is the proposition if, P if and only Q, if and only if. This is the meaning by conditional meaning. This double arrow means, what is the meaning? If and only if. Okay, what is the meaning of that one, if and only if? That means from here to here it should be true, here to here also it should be true. That is the meaning if and only if. That means P implies Q and Q implies P together. Okay, together it is coming means if and only if statement. So using the biconditional or double implication or double sided arrow, meaning is if and only if. Now what is the meaning? See here you can see the truth table. True if and only if true. That means true becomes true, true become true, opposite also true. So answer is true. Now true become false. True become false is false. False become true is true. So both not getting same answer. So it is false. Correct? Both should be correct. That is the meaning double implication. Now false become true. That is correct. But true never become false. So opposite side is not correct. So it become false. Now false become false, that is correct. Now if it is reverse, false become false also correct. So true. So when it will be true, both are true means it is true, both are false means it is true. All other case it is false. Hope you understood that one, correct? For example, P, you can take a flight, you can take the flight. Q means you buy a ticket. Okay, you buy a ticket. So what is the meaning of the double arrow? P if and only if Q. How to write? First you write P statement. Okay, you can take the flight. Then after that the biconditional means I told if and only if. That means the double side arrow, correct? Then the Q statement, you buy a ticket. So this is the English writing of that sentence. P if and only if Q, that notation. So you can take the flight if and only if. So wherever you see double arrow, you need to write if and only if, that one. That is the meaning of that statement. Okay, now we have some definitions, small definitions. What is the meaning? Compound proposition. Compound proposition means a proposition is a combination of two or more propositions and connected by one or more logical operation. So we are studied many logical operation now, either negation, okay, or operation, and operation we are studied, correct? And implication, double implication we are studied, correct? So we studied many operation now. So out of these operations, or also we studied, out of these operations, one or more operation, logical operation will come in a proposition and is connected by two or more propositions. See here in this example, we have P, we have Q, we have 3. How many propositions are there? Three proposition. So if we have two or more propositions, P, Q, R, like that, two or more proposition connected by one or more logical operation. For example, here see P, Q. P means it rained tonight. Q means I will stay at home. R means I will read book. Now see, I am writing one compound statement here. What is the compound proposition here? P implies Q and R. See how many propositions are there? Three. P, Q, R. How many logical connector is there or logical operations are there? Implies there and operation also there. Two logical operations are there. So we can say it is a compound proposition. Two or more proposition and one or more logical operation means it is calling a compound proposition. So how to write this compound proposition in English? In English you can say how to write this compound proposition in English. So first write P. What is P? It rains. You can see when you are writing P, it rains tonight. That is P, correct? But here arrow is there. Arrow means I told if P then Q. So first we need to start with the if and then. That is the arrow. If and then, that is arrow. So if it rains tonight, comma, then, okay, what is the then statement? In the bracket it is mentioned Q and R. So first we need to write Q. I will stay at home. Then we are using and. And means because this operation is there, logical, correct? So and. R. R means what? I will read a book. So read a book. That is the R operation. So when we are writing, how it will come? If it rains tonight, because if started because of arrow. If it rains tonight, then I will stay home and read a book. So that is the compound statement writing in English. Hope you understood. Okay. Now precedence of logical operation. Okay. Precedence of logical operation. That means the order. We have studied many logical operators. This one negation we studied. Second one and we studied. Or we studied. And XOR we studied. Implication. Okay, if and only if, by implication or by conditional. So which operation we will take first? Precedence of the logical operation. To know order of the operation in which logical operation of compound proposition is to be applied first. Which order we need to apply first? That is the meaning precedence of logical operator. So use parenthesis. Parenthesis means bracket to specify the precedence of the operation. For example, negation. Negation means we need to take negation first. Then and operation, then or operation, then XOR, then implication, then by conditional, if and only if. This is the order of the preference of this logical operation. Okay, so like board mass we are studied in number calculation, same idea. Okay, which operation we need to take first when we are calculating. Okay, now we will go to examples, exercise questions one by one. We will discuss exercise 1.1, question number 1. So what is the first question? Which of the following sentences are proposition? Which of the following sentences are proposition? That is the question. What are the truth values of those proposition? Truth value means true or false. Which one is true, which one is false? Okay, and what is it, proposition or not, like that. Okay, so we will answer one by answer also I will mention here. So I hope you understood the definition part. Briefly I explained. Now that definition using we are doing going to do the questions one by one. So first one, okay, 2 plus 3 equal to 5. 2 plus 3 equal to 5. It is a correct statement, correct? So it is true. Answer is true. True means it is a proposition, correct? Answer also I am given here. Okay, for reducing the writing and the time duration. Answer it is showing here. So 2 plus 3 equal to 5. It is a proposition because it is a true statement. Okay, so it is a proposition. Now x plus 2 equal to 11. Is it a proposition, this one? X plus 2 equal to 11. Can we say true or false like that? It is not a proposition because there is a free variable x. We don't know what is x, correct? There is a free variable is there. So sometime true, sometime false. We cannot say correctly true or false like that. Yeah. So it is not a proposition because it is a free variable inside it is. Okay, so this one is not a proposition, or non-proposition. Answer this question. Is it a proposition? Can we say true, false? Like, not a proposition, because it is just a command. Answer this question, like just a command, correct? So it is not a proposition. The third one also. Now D, question D. What time is it? What time is it? It is not a proposition, it is just a question, correct? It is not a proposition. We cannot say true, false like that the answers. It is not a proposition. E. The moon is made of green cheese. Is it true? No, it is false, correct? So it is a false statement, so it is a proposition. Proposition means either true or false, that sentence. False also proposition. So the moon is made of green cheese means it is a false statement, so it is a proposition. Now the F question. Paris is the capital of Germany. Paris is the capital of Germany. Is it true? It is not a true statement, because Paris means it is the capital of France, correct? So it is a false statement. False statement means it is a proposition. Hope you understood that one, correct? Germany means Berlin, it is the capital. So France capital is the Paris. So that statement is false. Now question number G. Nobody goes to the hotel. We don't know the truth value, correct? Nobody going to the hotel, just a statement only. So it is not a proposition. It is not a proposition. Nobody goes to the hotel because it is crowded like that. It is not a proposition. Okay. Now I will go to the second question. I hope you understood how to write proposition or not. Second one. What is the negation of each of these proposition? Negation. We need to write the negation of each of these proposition. Negation, this operation or this one, correct? What is the meaning? Not. Keep in your mind, not, opposite, correct? So first one, today is Friday. How to write the negation of that one? Just add it. Today is not Friday, correct? Just add the sentence not. Not. If you are adding not, if it is no there, delete. If there is no, add no. That is the meaning negation. So today is not Friday. Now we will go to the next one. There is no pollution in Egypt. There is no pollution in Egypt. So how to, see here already no is there. So when we are writing negation, delete that no. So how to write that one? The negation of this statement. There is pollution. There is pollution in Egypt. So I deleted that no, correct? So we are getting the negation of that statement. Okay, now next one, 2 plus 1 equal to 3. 2 plus 1 equal to 3, correct? What is the negation of that one? So we can write 2 plus 1 not equal to 3. Okay, we can write negation of equal to as not equal. Okay, not equal. So not equal to 3. That is the negation of that statement. Now question number D. Question number D. The summer in Muscat is hot and sunny. The summer in Muscat is hot and sunny. So how to write the negation? The summer in Muscat is, we can add not, correct? Not hot and sunny. Is not hot and sunny. So that is the negation of that statement. Hope you understood these questions. Now question number 3. Here answer also I mentioned. Okay, so for better understanding, so I can reduce the writing also. Time duration we can reduce. Okay, what is the question? Give the following propositions. P. I bought a lottery ticket in this week. This is the P statement. I bought a lottery ticket in this week. Q. I won the $1 million jackpot on Friday. That is the Q statement. Now what is the question actually? Express each of these propositions as an English sentence. We need to write in English. See, I am given the proposition like logical using logical connective and the propositional variables. Okay, this one, what is the meaning? You write in English, that is the question. Okay, so write the proposition or express the each of these propositions in as an English sentence, that is the question. So first one, negation of P. P opposite, negation of P, correct? So how to write? What is P actually? I bought a lottery ticket in this week. So what is the negation of that one? I didn't buy. I didn't buy, correct? Not, you can add a not statement. I didn't buy a lottery ticket in this week. Or you can write simply, I did not buy. Not, you can add, I did not buy a lottery ticket in this week. Like not, you can add. Okay, more than the grammar, that logical sentence, very careful. Okay, whatever we needed, you can add in simple way also. Okay, there is some logical equivalent statement also we can create from here. Okay, now B statement, P and Q, because you know this symbol means and, correct? This symbol means not, but here and, P and Q. So how to write? First you write P sentence, I bought a lottery ticket in this week, that is P. Then you use and, because this symbol is there, and then you write what is Q. I won a lottery ticket, $1 million jackpot on Friday, correct? So P and Q, you can just write in English. First write P, then for this symbol we are using and, then Q statement. Hope you understood that one, correct? Now we'll go to the next one, negation of P and negation of Q. Negation of P, P opposite, and negation Q, because this is and, correct? So how to write? First write negation P. P negation, I bought a lottery ticket in this week, using not. That means I didn't buy a lottery ticket in this week, that is negation P. Then use and, because we have and operation. Negation Q. Q means I won a lottery $1 million jackpot on Friday. So opposite of that one means I didn't win the $1 million jackpot on Friday. That is negation of Q. P, negation of P and negation of Q. So whatever you understood, you can write in simple way. P opposite, not add, not, correct? Then and, that logical connective. Negation Q, Q opposite, Q using not, you can write a Q statement. Okay, now we will go to the next one, negation of Q. Negation of Q, Q using not. So I didn't, this is negation. I didn't win the $1 million jackpot on Friday, negation Q. Q using not sentence. Now P or Q, this operation we are calling or operation, correct? P or Q. So how to write? First write P, then or, then Q statement. So first I write P statement, I bought a lottery ticket in this week, that is P. After that or, because we are using or operation. Q, I won the $1 million jackpot on Friday, correct? I bought a lottery ticket this week, or I won the $1 million jackpot on Friday. Hope you understood this question. Question number E also. Now see the same question I am continuing. Question number F, the same question only. I bought a lottery ticket in this week, I won $1 million jackpot on Friday. Write in English sentence. Up to E we did. Now question number F. Question number F means the negation of P or Q. This is or, correct? Negation of P or Q. So how to write that one in English sentence? You can think. First negation of P. Negation means I didn't buy a lottery ticket in this week, correct? That is negation P. Or, you can see or symbol. Then negation Q, I didn't win the $1 million jackpot on Friday. Hope you understood that one. Easy. Now P implies Q. P implies Q. What is the meaning? This one-sided arrow I told. If, then you write P, comma, then you write Q, correct? So how to write that one? First we write if, and then will be here surely. Then if I bought a lottery ticket this week, P statement. Then I won the $1 million jackpot on Friday, that is Q statement. Okay, so one-sided arrow coming means just write if and then, if then. Now here see, you can see negation of p, negation of p and negation of key q in between one-sided arrow. That means if, we need to start with the if and then. First write I didn't buy the lottery ticket in this week, negation p, correct. Then I didn't win the $1 million jackpot on Friday, negation q, correct. So that is the English sentence representing that that expression. Okay, now p double-sided arrow, if and only if, correct. This meaning is if and only if, correct. So p and q. So first write p, I bought a lottery ticket this week. After that, if and only if, that biconditional. Then q, I won a $1 million jackpot on Friday. So first write p, then if and only if, then q statement. Now you can see one compound statement here. Negation p, you can see that statement. Negation of p, or, this is or, p and q, correct. So how to write that one? First or, either or, correct, either or is the or symbol, either or. So either I didn't buy a lottery ticket on this week, negation p, p negation. Whatever that expression, same you can write in English, okay. Either or means either or. So either I didn't buy a lottery ticket in this week, or the second one, p and q. P means I did and I won a $1 million jackpot on Friday. Because I did and I won, I write it together because here and, correct. You can write I did the first one, p you can write I bought a lottery ticket in this week and I won the $1 million jackpot on Friday. That also correct. But grammatically when we are writing, this one is the correct one. But logically, equivalently, you can write either I didn't buy a lottery ticket in this week, or what you write, I bought a lottery ticket this week and I won the $1 million jackpot on Friday. That also correct only. Okay. So this is the idea how to express the logical expressions by using English sentence. Hope you understood. You can practice some more questions so that it will be easy. Okay, now we will come to the fourth question. What is the fourth question? Given the following proposition. Some propositions are given. P means it is below freezing. Q means it is snowing. P means it is below freezing. Q means it is snowing. Write these propositions using P and Q and logical connectives. Using P and Q and logical connectives. That means we need to write the expression. Not English sentence is given. You need to write the expression using P and Q and logic connectiveness. Correct? So we can check one by one. First one, A part. See, it is below freezing. That is P actually. And, and operation, this operation. And snowing. Snowing means Q, correct? It is snowing means Q. So what is the expression actually, proposition using P and Q and logical connective? P and Q, correct? It is below freezing, that is P. And means that and symbol. It is snowing means the Q symbol, correct? The Q letter. So P and Q, that is the expression there. I hope you understood. Now second one, the second question, B part. See, it is below freezing, that is P, correct? It is below freezing means P, but not snowing. Not snowing means negation Q, correct? Q means snowing, not snowing means negation Q. Okay, both will be there. It is below freezing and not snowing, but here we can see and like and symbol. So we can use P and negation Q, correct? But means this both will be there. Both means it is we are calling and symbol, correct? Now C part. The C part of the question you can see. Okay, what is C part actually? It is not below freezing. Not below freezing. That means negation of P. Not below freezing. Below freezing means P. So not means negation P. And see and symbol. It is not snowing. Negation Q. So what we can write? Negation P and negation Q. Correct? Negation P and negation Q. Hope you understood that one. It is easy. Read the line one or two times so that you can easily clear. Now we will go question number D now. Question number D. It is either snowing or. Either or means I told or symbol. Correct? It is either snowing. Snowing means Q. Or below freezing. Below freezing means P. Or both means both also happening. So or symbol. Not both means we will not use the or symbol. That's what I wrote or both like that. Not both means XOR symbol actually. Okay. It will come another example that one. So it is either snowing or below freezing means we can write Q or P. P or Q also correct logical equivalent. Now question number E. We can go question number E now. It is below freezing. It is also snowing. It is below freezing. It is also snowing. That is question number E. Question number E. If. Okay. If and then. Okay. Then also means then. Next sentence is coming. So it is below freezing means what is the meaning? P. It is also snowing means Q. Correct? If means one arrow. So how to write that one? P if Q. Correct? P implies Q. Okay. Now we will go to the next one. Question number F. It is either or but not both. Keep in your mind, either or not both means XOR symbol. Okay. Either or both means or symbol. I will write here. See, either or means or symbol. Okay. Either or not both means XOR symbol. So either or both means or symbol. Okay, we studied. You can write here. This is or symbol or this is XOR symbol. Okay, so keep in your mind this difference when you are doing questions especially. Okay, now we'll come to this one. Okay, come to this one. It is either below freezing. Below freezing means P. It is snowing means Q. But not both means XOR operation. So P XOR operation Q. Clear? Now question number G. Question number G. It is either below freezing or it is snowing. Either or. Correct? Below freezing means P. Snowing means Q. See, this is like one sentence here. So we can write P or Q. This is one. Now again this sentence is continuing. But it is not snowing. Not snowing means negation of Q. If, see here if is coming. It is not below freezing means, what is the meaning? Not below freezing, negation P. Correct? But if is coming. If statement first we are writing. If statement. So what we are writing that one? Negation of P. First we need to write. Negation of P. If means arrow mark. Correct? Not snowing means negation Q. Negation Q. Both are true. See, it start with but, like it is like and, that statement. So in between we need to put the and symbol because both are correct, both included. So P or Q and negation P implies negation Q. So if statement, if coming statement you need to write first. That is why I write negation P first. After that put arrow, then it is not snowing, that one, negation Q. Hope you understood that one. Okay, careful that question. Okay, now question number H. it is below freezing is necessary and sufficient. Necessary and sufficient means if and only if. That is the meaning, necessary and sufficient. Double arrow. Okay. For it will be, it to be snowing. Snowing means Q. This is P. So what we are writing? P if and only if Q. Double sided arrow Q. So necessary and sufficient, I explained before when I told the definition also. So just to see that table, necessary and sufficient, how I marked there. So you'll get more idea about that one. So necessary and sufficient, whenever you see, meaning is double sided arrow, if and only if. Okay. Now I will go to the next question. Question number 5. Question number 5. Determine whether these biconditionals are true or false. So we need to write either true or false. True means use capital T. False means capital F. So down statement is true or false. That is the question. Okay. So we will go to the question here. We will do the question. Okay. So 2 plus 2 equal to 4 if and only if 1 plus 2 equal to 2. This is the question. 2 plus 2 equal to 4 if and only if 1 plus 1 equal to 2. See here, P means 2 plus 2 equal to 4. The first statement. Q means 1 plus 1 equal to 2. Correct? Just for your understanding I am telling P and Q. P means 2 plus 2 equal to 4. That means the first statement. This is P. This is Q. If and only if means the double arrow. Correct? Double sided arrow. So how to write? For example, 2 plus 2 equal to 4. Is it true or false? It is true because 2 plus 2 is 4. If and only if means this double sided arrow, biconditional. 1 plus 1 equal to 2. 1 plus 1 equal to 2 is true. Correct? 1 plus 1 equal to 2 is true. So first one P is true, second also true. In between if and only if operation. So what will be the answer getting? Answer true if and only if true. We are studied the truth table, correct? It is true. It is true. True if and only if true means true, because true implies true, true implies true. Both are correct. So answer is true actually. Okay. Answer is true. Hope you understood. Okay. Just to see this one in your truth table. Truth if and only if truth means truth is the answer. Okay. Now let me go to the next one. 1 plus 2 equal to 3. That is P. If and only if, double arrow, correct? Double sided arrow. 2 plus 3 equal to 6. That is Q. This is Q. This is P. Okay. We will see the truth value. 1 plus 2 equal to 3. That is true. Because 1 plus 2 is 3. True that one. If and only if 2 plus 3 equal to 6. That is false. 2 plus 3 means 5. But it is 6 is written. So false. Correct? So P statement 1 plus 2 equal to 3. This is true. And Q statement 2 plus 3 equal to 6. This is false. Now true, you can see, now true if and only if false. What is the answer? It is false. Correct? So what is the answer? Answer is false. Okay? Because true if and only if we are studied the truth table, it is false. So answer is false. Hope you understood this question. Okay. Now let me go to the next one. Question number 6. Determine whether these conditionals are true or false. Conditional statement. Before we studied biconditional, if and only if statement. This question was biconditionals, correct? If and only if. Now here conditional. That means one side arrow. Okay. Determine whether the conditional statements are true or false. Okay. So we can see here. If you can see if means if and then means arrow, correct? If now 1 plus 1 equal to 2. This is the P statement. 1 plus 1 equal to 2. Is it true or false? P statement? True. Correct? Now, 2 plus 2 equal to 5. This is Q. Q means 2 plus 2 equal to 5. Is it true or false? 2 plus 2 is 4. So, 5 means it is false. So, how to write the answer? We can say 1 plus 1 equal to 2 means true. And 2 plus 2 equal to 5 means false. True implies false. What is the answer? True implies false. True never false. So, it is false. Correct? So, what is the answer we are writing? Answer is false. Hope you understood. Okay. You can check the truth table if you want. We studied true one-sided arrow, false. True implies false means false. Okay. Now we will go to the next one. If you can see if and then. If and then means arrow mark. 1 plus 1 equal to 3 means the P statement. 2 plus 2 equal to 4 means the Q statement. So 1 plus 1 equal to 3 means it is false because 1 plus 1 is 2. 2 plus 2 equal to 4 means it is true. Correct? So false implies true means what is the answer? True. Correct? So what is the answer we are writing? Answer is true. Hope you understood. Okay, now we will go to the next one. Question number 7. 7 is the truth table construction related question. So construct the truth table. That is the question. Construct the truth table. We need to create the truth table of each of the following compound propositions. Some compound propositions are given. You need to construct what is the truth table related to that one. Okay. So we will go to here. P if and only if Q. XOR P if and only if negation P. Negation Q. Sorry. Okay. All of you remember the precedence of the logical operator, which one we are taking first, which one we are taking second, like that. Correct? So before that, you can see how many variables are there. How many variables are there in this operation? Variables are P and Q. So how many variables? 2 variables. So first we can write P variable, second write Q variable. Correct? 2 variables are there. So how many rows will be there? How many rows? Number of rows means 2 power 2. That means 4. 2 power number of variables. 2 power 2 means 4 rows will be there. So you can see this is the first row, second row, third row, fourth row. Correct? We have 4 rows will be there. So that is why I drawn this table like this. Okay. 2 power 2, 4 variables. Now I told you how to take that variable. We have P and we have Q. So first variable either true or false. Second one, first to true means either it will be true or false in second. Same here also, true or false, that I explained before. Hope you understood. So here I am writing true and true. True and false. False and true. False and false. I explained before. You can check there also. Okay, if you not understood, from this tree diagram, first to true, true, then true, false, then false, true, then false, false. 4 option will be there. Okay, 4 rows. Now, what are the operation now we are taking? Okay, whenever we are creating truth table, bracketed operation first we need to do. Whatever coming in bracket, that is first. After that only outside bracket. So, see first bracket P if and only if Q. I can write P if and only if Q here. First I am doing this one. After that what I want to do? I want to go the second bracket. But second bracket if you want to do, first we need to do negation Q. Then only we can go that bracket. So first you do negation Q. You can use this operation also, this symbol also. Negation Q. After that this full bracket. P if and only if negation Q. Hope you understood. Because negation Q, whenever we finished only, we can do P if and only if Q. So that's why we did first negation of Q. After that, P if and only if negation Q. Then once you finish this bracket and this bracket, totally we can do, correct, in the last column, that is P if and only if Q XOR operation P if and only if negation Q. Okay, like this. So we will do one by one. First P double sided arrow Q if and only if Q. So true if and only if true means it is true. Okay. Then second one, true if and only if false. False means it is false. You know the logical operation. False if and only if true means the false. False if and only if false means true. Correct? We can fill one by one. P value we know, Q value we know. Then if and only if operation we can give. Use the truth table, whatever we discussed. Now negation Q. Negation Q means opposite of Q. For example, first Q is true. Correct? So what is the negation of that one? False. Second one is false. So it becomes true. Third one is true. So it becomes false. Fourth one false. So it becomes true. Opposite of Q. Q symbol operation. Okay, opposite. Now P if and only if negation Q. So this table and this table. P if and only if negation Q. So how to write P if and only if negation Q? True if and only if false means true if and only if false means false. Okay. Then true if and only if true. Again false if and only if true. False true means false. Okay, you can practice, write and practice so that you will get easily. Okay, now we will go to the last one. P if and only if Q. XOR operation P if and only if negation Q. That means you need to consider this and this XOR operation. XOR. Okay, XOR operation. So true XOR false. True XOR false. One of them true is true. We studied, correct? False XOR operation true. False XOR operation true. True XOR operation false. True. Okay. So all are true. All are true. In the final answer, final column, all are true. If all the column in the final row, for all the rows in the final column complete true. See, here true, here true, here true, here true. All are true in the answer means we are calling it is a tautology. This operation is a tautology. That means our question is a tautology. Tautology means complete true. We will get the answer. All the row true. That is tautology. Hope you understood this question. You can practice. Okay. Now this one. One more. Question number 7E. Are XOR operation P or Q? How many variables are there here? P, Q are 3 variables. So variables we can write, we have P, we have Q, we have R. So how many variables are there? 3. So how many rows? Number of rows equals 2 power 3. 2 power number of variables 8. 8 row will be there. Okay. So 8 rows we need to create. Here see 1, 2, 3, 4, 5, 6, 7, 8. 8 rows will be there. So we will write the first proportional variables P, Q, R. Correct? Now what are the truth values as I told you before? We have P, we have Q, we have R. So first proportional variable either true or false. Now second one also either true or false. Correct? Third also either true or false. Either true or false. True or false. Either true or false. This is the tree diagram. Easily you can understand this one. So first row true, true, true. Correct? So I can fill here true and true and true. Now same way we will continue. Second one true, true, false. Correct? True, true and false. Now the third one we can write true, false, true. True, false, true. You can check that tree diagram when we are doing. Then TFF, TFF. After that FTT. Then FTF. Then FFT. Then F, and F. Okay, the 8 rows we have written. Now we will go to the truth table values. First, what we need to do? We need to do the bracketed term, correct? That means P or Q. First preference for bracketed term. So P or Q. So we can take P or Q, or symbol in between. True or true. That means true. Or symbol, one of them true, it is true, correct? True or false, sorry, true or true, true. Again, true or false, true. Then again, what we will get it again, P or Q. True or first one, true or true, true. True or true, then true. True or false, again it is true. Then third one, sorry, fourth one, true or false. That means true. False or true, that also true. Then again, false or true, that is true. Then again, false or false, it become false operation. Then false or false, it become false. P or Q, correct? P or Q. Now we will go to the last one, that is R XOR operation P or Q. R XOR operation P or Q. So we can go the columns. What are the columns? We can highlight. You can see this one and XOR this operation, correct? So XOR operation, what we told, both are true means it is false, correct? Both are false. One true means true. So we can see here true, true, this becomes false. False, true, it becomes true. Then true and true, it becomes false. Then false and true, it becomes true. Then we can see here true and true, it becomes false, and false and true, it becomes true. True and false, it becomes true. False and false, it becomes false. Hope you understood that one. Okay, hope you understood this table. So this is the question here related to this expression, this truth table. Hope you understood this one. Okay, now we will go to the next one. You can check this one. There are many questions. You can solve any one, whatever you want here from here. Any question you can solve from here. That is for your practice I am giving. One of the question I can do here, any one. For example, I can do question number 7 D part. This question 7D. I can show here in the next page. Question number 7D, the truth table. That means P XOR Q, P XOR operation Q gives P and Q. P and Q here, correct? So we will do this question. So first we can check how many variables are there. Variables P or and Q only, 2 variables. So number of rows we can write 2 power 2. That means 4 rows will be there. So we will create the table here. So first P, then Q. We need 4 rows, correct? So we can write what are the 4 rows. True and true, true and false, false and true, false and false, correct? Now we will go to the table one by one. So first we need to do the first bracket. That means P XOR operation Q. After that we will do the second bracket, P and Q. After that we will do the total operation, P XOR Q implies P and Q here, correct? Yeah. Now we will answer here one by one. First P XOR Q. True and true XOR true means it is false. Both true means false. True false means true, correct. False true means true. False false means false, correct. One of them true, true, otherwise false. Now P and Q. P and Q. Both are true, true, otherwise false. So true and true, true. True and false, false. False and true, false. False and false, false. Now we are using the implies one-sided arrow. This one and this one we are using implies operation, correct? One-sided arrow. So now we can answer the question. False implies true, correct? False implies true, that is true. True implies false, it is false. True implies false, false. False implies false, that is true. So this is the truth table related to this operation. Hope you understood this question. Question number 7D. Now same way you can practice any of these questions. All are easy questions only, not much difficult questions. So just to prepare the rows, how many rows we needed, then each operation. I will give the idea here when you are preparing here. First you prepare P, then Q, then R, correct? After that P and Q, okay, because first bracket. Then P and Q and R, correct? One by one we can prepare. Now here, when we are doing this one, first 3 variables are there. So we can write P, then Q, then R. After that, see, before this bracket you need to do negation Q. So negation Q. After that the bracket R and negation Q. After that the negation P also needed here. See, negation P, okay, like this. Then last the final one, that is R and negation Q implies negation P. So that you will get answer. This is the last one. This already did. Now here, this one when we are doing, 3 variables are there, P, then Q, then R. So first to P, then Q, then R. Okay, then after that you need to do here negation P, then P and Q here, then negation P and R. After that the complete P and Q or negation P and R, correct? This one. So you can do order one by one like this. Now question G also same like this. First P, then Q, then negation Q we need to do. After that P and negation Q we need to do. After that P and Q we need to do. After that P and negation Q implies P and Q, this table. You can practice one by one the questions, okay, these questions. Okay, now let me go to the question number 8 here. Question number 8. Write the converse, inverse, and contrapositive. That is the question. Write the inverse, converse, and contrapositive. So these three: converse first, then inverse, then contrapositive. First, P gives Q. So the first question, A part, P gives Q. What is the converse actually? Write in the reverse. Q implies P, correct? Inverse. Inverse means what we do for the inverse. This statement negation. Negation of the statement. That means negation of P implies negation of Q. Negation of P implies negation of Q. Now contrapositive. Contrapositive means converse inverse. Okay, converse negation. Converse negation. That means negation Q implies negation P here. Hope you understood. Now same like we need to do the question number B. B part. T gives negation W. T gives negation W. T gives negation W. This is the statement. So first converse. Negation W implies T, correct? Now, after that we need to write what is the inverse statement. Inverse means statement negation. So negation T implies negation. Negation W means W, correct? Contrapositive. The negation of the converse statement. So negation of negation W means W gives negation T. Hope you understood that one. Now question number C. Negation of M implies P. Negation of M implies P. So first converse, write in reverse. P implies negation of M. Then inverse statement negation, that is negation of negation M means M implies negation of P. After that contrapositive, converse negation, that is negation P implies M. Now we have to do the question number D. Negation of P implies negation of Q. So first converse, write in reverse. Negation Q implies negation P. Then inverse. Inverse means original statement negation. Negation of negation P means P implies negation of negation Q means Q. Then contrapositive means converse negation, correct? So Q gives P, because negation coming two times means original it will come. Hope you understood this one. Next question number 9. Question number 9. So we will go to this question now. Question number 9. Write the converse, inverse, and contrapositive in words. We need to write in words. Converse, inverse, and contrapositive in words. That is the question. That is an English statement. If you use charm face powder, then you will be beautiful. This is the statement. If, you can see if statement, and then, that means the arrow mark, one-sided arrow, correct? If and then. So what is P here? You use a charm face powder. You will be beautiful means it is Q. Okay, so P statement identify and Q statement identify. After that you write what is converse, inverse, and contrapositive. So P means, what I write P, you use charm face powder. Q means you will be beautiful. Okay, if and then means arrow mark. So original statement means P implies Q, correct? Now we need to write what is the inverse, converse, inverse, and contrapositive. So first write converse. Converse means what we need to write? Q implies P. We need to reverse just before we discussed it, correct? Q write first, then arrow mark P. So how to write that one? Arrow mark means if. We need to start with if. You will be beautiful. That is Q statement. Then, correct? If and then means arrow mark. then you need to write P statement. Q gives P, that is converse. So if you will be beautiful, then you use charm face powder. Here more concentrate in this expression. Okay, more than the grammar, concentrate the expression here. You can write in good grammar also, that are all logically equivalent. Now, inverse. What is inverse actually? Original statement negation. That means negation P gives negation Q. This is inverse, correct? So how to write inverse? First if, because arrow mark is there, if and then should be now. Negation of P. P negation. P means you use charm face powder. So how to write negation? You are not using charm face powder. Negation P. Then negation Q. You will not be beautiful. That is negation Q. You can see not, both cases, correct? Negation we are used. So negation of P implies negation of Q. That is inverse. That is, if you are not using charm face powder, then you will not be beautiful. Now contrapositive means converse negation. That means negation of Q implies negation of P. So how to write that one? First implies symbol is there. So if and then, correct? Then you write negation Q. Negation of Q. What is Q? You will be beautiful. So what will be negation? You won't be beautiful. You will not be beautiful. Correct? Then negation P. Negation P means you don't use charm face powder. You use charm face powder is P. So you don't use charm face powder is negation P. So if you want to be beautiful, then you don't use charm face powder. So that is the English sentence representing converse, inverse and contrapositive. Okay, now we will go the 9th question. One more question, same model we can do. Remaining you can try yourself. For example, this one. Write the converse, inverse and contrapositive of the statement in words. When you use imported sparkling water, it shows that you have good taste. Correct? So what I am taken, you serve imported sparkling water. That is, we are taken P. You have good taste. That is, we are taken Q. You have good taste. That is, we are taken Q. So original statement is P implies Q. Correct? P implies Q. That means when you use when we serve imported sparkling water means bubbled water. Okay, bubbled like soda, like Pepsi, like this sparkling water. It shows that you have good taste. Okay, so if statement P implies Q, that is the original statement. So first you need to write converse. Converse means Q implies P. Inverse means negation of P implies negation of Q. Contrapositive means negation of Q implies negation of P. Okay, we need to write in English all these one. P and Q already identified. When you serve imported sparkling water, that is P, and you have good taste, that is Q. So we can go one by one. First Q gives P, converse. So Q implies P, so that you can see if, correct? If you have good taste, you have good taste means Q. Then you serve imported sparkling water, that is P. So Q implies P, correct? That is the converse statement. Now inverse statement, negation of P implies negation of Q. You can write, I have written here two ways. One of the way you can write, so negation of P, if, starting with the if first, negation of P statement, you didn't serve or you don't serve imported sparkling water. Then negation of Q, you don't have good taste, correct? So negation of P, here negation of Q, this is correct only. Same you can write in the top also, like this also. When you have not served imported sparkling water, not, you can see not, this is negation P. It shows that you don't have good taste, you have not good taste, that is negation of Q here, correct? So this also correct only, both are logically equivalent, up to you. So as I told you, more than grammar, you can correctly clear that logical expression when you are writing, okay, these cases. Okay, now contrapositive. Contrapositive means negation of Q implies negation of P. What is negation of Q? If you don't have good taste, you have good taste is Q. So negation of Q means just opposite. negation of Q, then you do not serve imported sparkling water, negation of P here, correct? That is the contrapositive. So like this we can write any sentence, inverse, converse, contrapositive, all these things, but we need to careful about the logical connectiveness. Okay, connectives write correctly, okay, by the sentence. Okay, now you can do these questions as homework, same model whatever we did, like you can practice these questions whenever you are doing that one, practicing time. So I hope you understood the first section. Thank you for watching. Please subscribe my channel for getting more recorded classes. Thank you very much.